What is MPLS? Wormhole switching, message switching, packet switching, circuit switching, network switching, cut-through switching, virtual circuit packet switching. Multi-protocol label switching, MPLS. Multi-protocol label switching, MPLS, is a routing technique that augments speed and control of the network traffic by directing data from one node to the next node based on short path labels. Instead of being routed using long network addresses, the data packets are routed through path labels that identify virtual paths between the nodes rather than endpoints. MPLS speeds up traffic flows by avoiding complex lookups in the routing table at each node as in conventional routing algorithms. MPLS is a scalable and protocol-independent routing technique. It works with Internet Protocol, IP, Ethernet, Frame Relay and Asynchronous Transport Mode, ATM. Despite the advent of newer technologies, it remains relevant due to its features like security, flexibility, and traffic engineering. Working principle. MPLS works by prefixing 32-bit labels with the MPLS header. The 32-bit label contains 4 fields. Label value field of 20 bits. Traffic class field of 3 bits for QoS, quality of service. Bottom of stack flag of 1 bit, 1 value denotes that the current label is the last one in the stack. TTL, time to live, field of 8 bits. When an IP packet enters the MPLS network, the 32-bit MPLS label is added by the ingress router, which is a label edge router, LER. LER decides the virtual path called label switched path, LSP, that the packet will follow until it reaches its destination. The subsequent label switching routers, LSRs, along the LSP, forwards the packet based upon only the MPLS labels. They do not look beyond the MPLS label to the IP header. When the packet reaches the egress router, also an LER, the MPLS labels are removed and the original IP packet is forwarded towards the final destination. What is wormhole switching? In data communications, wormhole switching, a flow control technique where large data frames or packets are partitioned and then transmitted. When a switching device, a bridge or a switch, receives a data packet, it partitions the packet into small parts called flow control units or FLITs. The FLITs are transmitted one by one instead of the whole packet. Also called wormhole flow control. Wormhole switching is subtype of FLIT buffer flow control methods and is based upon fixed links. Working principle. In this technique, each packet or frame is broken into smaller pieces of data called FLITs. The header FLITs contain the destination address and other routing information for all of the FLITs comprising the packet. The header FLITs are followed by body FLITs and finally tail FLITs denoting end of the data packet. The buffers and channels are allocated on FLIT levels rather than for the entire packet. When the header FLIT arrives, a free buffer is allocated to the entire packet. The header FLIT is forwarded as soon as the routing information is decoded without waiting for arrival of rest of the FLITs. The subsequent FLITs are allocated to the same buffers before forwarding them. Once a buffer is full, no more FLITs can be allocated. The tail FLITs free up the buffer. Uses. Wormhole switching is usually deployed in multi-computers and for real-time communication due to low latency and lesser memory requirement of switches. Advantages: low latency. Since the switching device does need to transmit the entire frame together, the latency of passing through the switch or bridge is reduced considerably. Less storage requirement. The switching devices do not require to store the entire data packets or data frames in it. Instead, they need to store only small-sized flits. So, they can operate with reduced internal storage capacity. Guaranteed delivery of packets. Since they are used for reliable connections, it guarantees transmission of the data packets. What is message switching? Message switching is a connectionless network switching technique where the entire message is routed from the source node to the destination node, one hop at a time. It was a precursor of packet switching. Process: packet switching treats each message as an individual unit. Before sending the message, the sender node adds the destination address to the message. It is then delivered entirely to the next intermediate switching node. The intermediate node stores the message in its entirety, checks for transmission errors, inspects the destination address, and then delivers it to the next node. The process continues till the message reaches the destination. In the switching node, the incoming message is not discarded if the required outgoing circuit is busy. Instead, it is stored in a queue for that route and retransmitted when the required route is available. This is called store and forward network. Advantages: sharing of communication channels ensures better bandwidth usage. It reduces network congestion due to store and forward method. Any switching node can store the messages till the network is available. Broadcasting messages requires much less bandwidth than circuit switching. Messages of unlimited sizes can be sent. It does not have to deal with out-of-order packets or lost packets as in packet switching. Disadvantages: in order to store many messages of unlimited sizes, each intermediate switching node requires large storage capacity. Store and forward method introduces delay at each switching node. This renders it unsuitable for real-time applications. What is packet switching? Packet switching is a connectionless network switching technique. Here, the message is divided and grouped into a number of units called packets that are individually routed from the source to the destination. There is no need to establish a dedicated circuit for communication. Process: each packet in a packet switching technique has two parts, a header and a payload. The header contains the addressing information of the packet and is used by the intermediate routers to direct it towards its destination. The payload carries the actual data. A packet is transmitted as soon as it is available in a node based upon its header information. The packets of a message are not routed via the same path. So, the packets in the message arrives in the destination out of order. It is the responsibility of the destination to reorder the packets in order to retrieve the original message. Here the message comprises of 4 packets A, B, C and D, which may follow different routes from the sender to the receiver. Advantages: delay in delivery of packets is less, since packets are sent as soon as they are available. Switching devices don't require massive storage, since they don't have to store the entire messages before forwarding them to the next node. Data delivery can continue even if some parts of the network faces link failure. Packets can be routed via other paths. It allows simultaneous usage of the same channel by multiple users. It ensures better bandwidth usage as a number of packets from multiple sources can be transferred via the same link. Disadvantages: they are unsuitable for applications that cannot afford delays in communication like high-quality voice calls. Packet switching: high installation costs. They require complex protocols for delivery. Network problems may introduce errors in packets, delay in delivery of packets, or loss of packets. If not properly handled, this may lead to loss of critical information. What is circuit switching? Circuit switching is a connection-oriented network switching technique. Here, a dedicated route is established between the source and the destination, and the entire message is transferred through it. Phases of circuit switch connection. Circuit establishment. In this phase, a dedicated circuit is established from the source to the destination through a number of intermediate switching centers. The sender and receiver transmits communication signals to request and acknowledge establishment of circuits. Data transfer. Once the circuit has been established, data and voice are transferred from the source to the destination. The dedicated connection remains as long as the end parties communicate. Circuit disconnection. When data transfer is complete, the connection is relinquished. The disconnection is initiated by any one of the user. Disconnection involves removal of all intermediate links from the sender to the receiver. Diagrammatic representation of circuit switching in telephone. It represents circuit established between two telephones connected by circuit-switched connection. The blue boxes represent the switching offices and their connection with other switching offices. The black lines connecting the switching offices represents the permanent link between the offices. When a connection is requested, links are established within the switching offices as denoted by white dotted lines, in a manner so that a dedicated circuit is established between the communicating parties. The links remains as long as communication continues. Advantages. It is suitable for long continuous transmission, since a continuous transmission route is established that remains throughout the conversation. The dedicated path ensures a steady data rate of communication. No intermediate delays are found once the circuit is established. So, they are suitable for real-time communication of both voice and data transmission. Disadvantages. Circuit switching establishes a dedicated connection between the end parties. This dedicated connection cannot be used for transmitting any other data, even if the data load is very low. Bandwidth requirement is high even in cases of low data volume. There is underutilization of system resources. Once resources are allocated to a particular connection, they cannot be used for other connections. Time required to establish connection may be high. What is network switching? Definition. Network switching is the process of transmitting data packets from the source to the destination through a number of intermediate network nodes. Here, each node controls or switches data packets to the next node towards the destination. When data comes on a node, it is called ingress, and when data goes out of a node, it is called egress. Switching methods. The two broad-level switching methods are connection-oriented switching and connectionless switching. Connection-oriented switching. In connection-oriented switching, a dedicated path is established between the source and the destination before data switching. Once this path is established, the entire message sent through this route. Connectionless switching. In connectionless switching, no path is established prior to data switching. Each data unit has complete address information and is individually routed from the source to the destination using forwarding tables of the nodes. Switching techniques. The three common switching techniques are circuit switching, packet switching, and message switching. Circuit switching. Here, a dedicated path is established between the source and the destination, and then all the message is sent over this route. It is an example of connection-oriented switching method. Packet switching. The entire message is broken down into small data packets, each of which has switching information in its header. The packets are then individually routed from the source to the destination. The destination node reassembles out-of-order packets according to header information. It is an example of connectionless switching. Message switching. It is a combination of circuit switching and message switching. Here, the entire message is considered as a data unit and is routed from one node to another in a connectionless manner. What is cut-through switching? In data communications, cut-through switching is a method of switching data frame or data packets where the switching device, bridge or switch, forwards the frames or packets as soon as the destination address is available without waiting for the rest of the data to arrive. Working principle. Cut-through switching is used in packet switching systems. In packet switching, the message is divided into a number of units called packets that are individually routed from the source to the destination. There is no need to establish a dedicated circuit for communication, since it is a connectionless network switching technique. In cut-through switching, when the data frame or a packet starts arriving at a bridge or a switch, data transmission can start as soon as destination address field has arrived. The switch performs a look-up at the address table stored in it to check whether the destination address is valid. If the address is valid and the outgoing link is available, the switching device immediately starts to transmit the frame to the destination port, even before rest of the frame has arrived. Here, the switching device acts as mere forwarder of frames. As the total frame is not yet available, it cannot perform error checks when it starts forwarding. It depends upon the destination devices for error handling. Advantages. The advantages of cut-through switching are: low latency. Since the switching device does not wait for the entire frame to arrive, the latency of passing through the bridge is reduced considerably. Less storage requirement. The switching devices do not require to store the data packets or data frames in it, so they can operate with reduced internal storage capacity. Uses. Cut-through switching is mainly used for communications via fiber channel. It is also used for SCSI traffic for the low latency transmission. What is virtual circuit packet switching? Packet-switched service transfers the data from source to destination. Data is transferred on a type of network in which small units of data called packets are transferred. Each packet contains a destination address within it, where it has to be received. This type of communication between receiver and sender is connectionless. The Internet is also a connectionless network. Most of the traffic over the Internet uses packet-switched service. Voice call over the Internet is a type of packet switching, where each end of the conversation is divided into small packets and is reassembled later into a complete message. Packets are made up of a header and a payload. Header directs it to the destination, and data in the payload is the actual data which is to be transferred. Types of packet switching network. The packet switching network is of two types. Datagram packet switching. Virtual circuit packet switching. Virtual circuit switching. It is a network where a virtual connection is established between source and the destination. Through this network, packets will be transferred during any call. The path established between 2 points appears as a dedicated physical circuit. Therefore, it is called a virtual circuit. It is a type of packet switching. It is a connection-oriented service where the first packet goes and reserves the resources for the subsequent packets. For examples, X.25 and frame relay. The pictorial representation of virtual circuit connection over a telephone call is as follows. Explanation. Step 1. Sender A establishes a call request connection to connect with the receiver. Step 2. Receiver B establishes a call accepting connection to connect with sender. Step 3. Data will be transferred whenever the router is established. Step 4. Node 1 and Node 2 are intermediate nodes between sender and receiver. The data will be transferred by connecting to nodes virtually. Step 5. After transmitting the data, an ACK will be sent by the receiver by saying a message is received. Step 6. A clear signal will be sent if the user wants to terminate the connection. Advantages. The advantages of virtual circuit are as follows. Packets are delivered in the same order as they all follow the same route between the source and the destination. The overhead is smaller as full address is not required on each packet as they all follow the same established path. The connection is more reliable as it is one-to-one connection. Less chances of data loss. Disadvantages. The disadvantages of virtual circuit are as follows. The switching equipment should be powerful. Re-establishment of the network is difficult as if there is any failure, all calls need to be re-established.